Hey guys, today we're going to take a look at the standard deviation, which is our second major measure of spread that we're going to learn in this course. Now the standard deviation is usually associated with the mean, and rightfully so. You'll have to use the mean to calculate it. So when you're talking about the mean, you're going to use the standard deviation as a measure of spread, rather than the interquartile range, which goes along with the median. Okay, so what a deviation is, because we're talking about the standard deviation, what a deviation is the difference between the individual value and the mean for the data. Okay, so it's a simple subtraction. So you can see I've already actually filled this out because I messed up my first video. So you just take the piece of data here, and you're going to subtract the mean. Now, it says for a population, and then over here we've got it for a sample. It's exactly the same, of course. It's just that we're using different notation. Okay, so for this, there is no other difference than that. The larger the size of the deviations, the greater the spread of the data is. Values being less than a mean will have a negative deviation. And if you were to add up all of the deviations for an entire data set, they'll actually all add up to 0. Okay, they'll cancel out. So what the standard deviation is the square root of the mean of the square of the deviation, which sounds incredibly simple, and I'm sure it makes perfect sense. But basically, it's just a way that we can describe data to sort of give this measure of spread. The bigger the standard deviation, the more spread out the data is. So what we use is this lowercase Greek letter sigma, which looks like this one right here. That's our sigma. And that's what we're going to use when we're talking about the standard deviation for a population. If, however, we're talking about for a sample, we're just going to use an S. And sometimes you'll see it as a capital S. It's actually traditionally a lowercase s, but sometimes, they get mixed up, and some people will disagree, but they're wrong. Anyway, so the formula we have for standard deviation is this one right here. So what you're going to do is you're going to take each piece of data, subtract the mean. You're then going to square it and then add all of those up. We then divide by n, which is the number of items in the population, and then take the square root of the whole thing. So it's not terribly hard, it's just as the data set gets bigger and bigger, it can be quite tedious to calculate. The sample standard deviation, first of all, obviously we use S, we use X bar, but the other difference that you need to notice is that we are using n minus 1 on the bottom, not n. And this is because when you're using a sample, you need to compensate for the fact that this is going to tend to underestimate the deviations in the population, which I've already actually written down here too. So anyway, the other thing that we'll talk about is variance throughout. And variance is, it's something that comes up not in ways that you'll expect. It's really just another way of talking about this measure of spread. And from it, you get the standard deviation. We mostly are going to use standard deviation, but you will hear variance discussed. And all it is the same thing, but you don't square root it. That's the only difference. And so not surprisingly, the notation then is the same as standard deviation, except with a squared, because that's all it is. And for the sample, again, same thing. You are using the n minus 1 on the bottom again, it's important to note, but again, it's just s squared. Okay? So here I've just already written out that n minus 1, the reason we do that is for all the reasons that I already said. Okay? So as we move on to the first example here, you'll notice that I did make some changes to the data set, and actually there's two questions here that use data sets. In one, I changed both of the data sets. One of them, it's just because when I did my answers, I used the wrong data set, to be honest with you. And this one here, it's just so that it works out easier. I wanted to use a smaller data set because it takes forever. So fortunately for you guys, down the road, I am going to teach you how to do this with a computer, and that will make your life a lot easier. But in the meantime, you will have to do this the long way. So what we're going to do, let's see, where is it? Oh, it's on the next page. If I can get this thing to flip pages. There we go. All right. So the first thing you have to do is you have to find the mean. So now, first of all, let's read the question here. So we're going to use means and standard deviation to the heights for two basketball teams. The assumption here is that this is the entire team. I realize there's 5 players and you would actually have subs on teams, but I think it's fair to say, oh, well, you know what, maybe not. Maybe let's say that it's yeah, you know what, I'm changing my mind. Let's say that this is a sample of the team. So we're going to say it's a sample. Realistically, on a test, if it's not crystal clear, then I will accept either one. But anyway, to find the sample, or to find the mean, you're just going to add them all up, divide by 5 in this case, and I am just going to jump ahead and tell you that the answer is 163. And on the next one, it is also 163, which is intentional that they're the same. Because we've got 2 teams, they have exactly the same average height. Okay, the question becomes, you know, which team, like, how do the 2 teams differ? If they're, like, do they look exactly the same? Because on average, they have the same height. But obviously, I wouldn't have done this question if that was the case altogether. So we're going to do the standard deviation. Okay, so what you do, so here, I'm going to zoom right in here. And we're going to take each piece of data, and we're going to subtract the mean. So for instance, I've got 183 is my first piece of data. I'm going to subtract the 163, and then I'm going to square it. And then I'm going to add the next one. So the next one I've got 161. I subtract 163. And then I square it. And what's interesting here is because we did talk about how the deviations will be negative if you're below the mean. But when we square it, that actually takes that into account. It gets rid of that. And so we end up dealing in positive numbers, which is good. So anyway, so we got 148 minus 163 squared plus 142 minus 163 squared plus 181 minus 163 squared, and I just fit. That was lucky. And I'm going to take that whole thing, and I'm going to divide by the n, which is 5, and then I'm going to subtract the 1. Okay, so throw that in your calculator, and you're just going to get, and you can, like, depending on your calculator, you can do this individual steps or you can do it all at once. Doesn't really matter, but you are going to end up with 18.67, or at least that's what I got when I did it. So there we go. So we've got a standard deviation, which I'm going to call S because we decided it was a sample, of 18.67. Okay? And it would be a little bit different if we decided it was population. Of course, because you'd divide by 5 instead of 4. So you get, yeah. So anyway, let's see. So we're going to do it for the Ravens now. Okay. And so again, you go through and we just take each piece of data. So we got 160 minus 163 squared. Did I write, you know what I didn't do? Hold on. Before I continue and realize that I messed this all up, I forgot to put the square root sign over all this. So there's a square root over that. And I did actually do that when I got the 18.67. So that does include the square root. So sorry about that. So now we're going to go through. We've got 163 minus 163 squared plus. And we've got 166 minus 163 squared plus. And you can see these deviations are a lot smaller. So not surprisingly, we're going to end up with a much smaller standard deviation. So why did I do a point? That's supposed to be a minus 163 squared plus 162 minus 163 squared. All right, once again, we divide the whole thing, and I'm going with the 5 minus 1 this time. And I square root it. And what I'm going to end up with is 2.24. Okay? So what's important here is that this is much smaller. Okay? And what that implies is that the height of the players is much more consistent. Okay? So we'll say consistent. No, that's not how you spell consistent. Height on team. Okay, so in other words, that's how you spell team. Wow. I'm doing really well today. Anyway, so what this means is with the first team, which I can't remember what they were called. Oh, they were the Falcons. Okay, so the Falcons, you've got really short people, you've got really tall people. But the Ravens, they're all just pretty much the same. Nobody's super tall, nobody's super short. They're all kind of in the middle. Okay? So, let's do frequency mean. So we talked, in the interquartile range lesson about how to do it when we're dealing with frequency charts. And we can do that using this as well. Okay? So to find the frequency mean, which we've already talked about this. This was when we talked about in the last... or when we talked about central tendency. So you are just going to add up the frequency of the piece of data times the piece of data, and then you're going to divide the whole thing by the sum of the frequencies. So that was our frequency mean. Now you'll notice I did it as an X bar here. Yeah, I'm actually going to change my mind on that, and I'm going to say I'm going to write that as a mu for this particular thing. Again, it's not, I'm acting like it's a big deal. It's not at all, to be honest. As long as you understand what the difference is, it's really not that big of a deal. Okay, so anyway, so the standard deviation, which is the new one, what you're going to do is you're going to add up the frequency of the deviation, so xi, minus the frequency mean, and then you're going to divide the whole thing by the sum of the frequencies. Okay? Although you know what though? I believe there's a squared missing on that formula. In fact, I'm positive there's a squared missing on that formula. So add that squared. There we go. So now we're going to go through, and once again, you'll see that I changed the data set. So please use the data set that I'm using here, just because otherwise your answers will be different. You're welcome to try it with the other ones and see what you get, of course. But we're going to go through here and do this. So first of all, cumulative frequency. So this is just keeping track of how many people there are. So we have one person in the first column. We had 5 more people, so we're at 6. We had 7 more people, so we are at 13. We had 7 more people, so we're at 20, and we are at 26. So there you go. So we got 26 people. So the first thing we're going to do is we're going to calculate the mean. So it is a frequency mean, obviously. So we're going to add the frequency times the data over the sum of the frequencies. So in this case, we're going to have 1 times 13 plus 5 times 32 plus 7 times 35 plus 7 times 38 plus 6 times 42, and we're going to divide the whole thing by the sum, which we already said was 26. Okay, and so you figure out what that is, and it works out to 36. So our mu is 36. All right. So the next thing is we're going to find the standard deviation, which I didn't leave myself a ton of room. Actually, you know what? I bet yep, I did leave myself more room. Okay, so let's do it over here on the next page because we have tons of room on this page. So here we go. So the first thing, formula, we got square root of, we're going to have the sum of the frequency times xi minus mu f and squared, and then we'll divide them by the sum of the frequencies. Okay, so what you're going to do, you're going to say, all right, well, we've got 1 times, and then we had 13 minus the 36 squared. Make sure you square those brackets before you multiply by, well, in this case it's by 1, so it wouldn't make a difference, but in the next one, make sure that you find the difference, square it, then multiply by 5. Of course, if you're just putting it into your calculator, it will not make a difference, because your calculator will do it for you. But as long as you type it in right. So we go through, we got 5, we've got 7 times 35 minus 36 squared. We've got 7 times 38 minus 36 squared plus 6 times 42 minus 36 squared. And then we divide the whole thing by the 26. Okay, and then of course don't forget, and I always forget to write it. I never forget to do it, but I always forget to write it. Make sure you do write your square root for the whole thing. And that is going to work out to 5.75. So we have ourselves a standard deviation of 5.75. And that's it. That's all there is to it. So like I say, I mean, depending on your data set, I've given you pretty small data sets here, and that's going to keep your calculations down to a minimum. But if you get big data sets, which a lot of the times you'll have, the calculations can get pretty tedious, and that's where we're going to start to use Excel later on in the unit so that we can figure out how to do that. So anyway, that's it for this time. Until next time, go Sabres!